I hope I am audible there. Can someone confirm?
Yes, sir. You are audible.
Yeah, thank you, Anchal, for confirming. So I welcome all to this live session of this course on manufacturing of turbines. If any participants have joined, so please feel free to ask your queries. So I will be happy to address them. Thank you.
Hello, good afternoon, sir.
Yeah, yeah. Good afternoon.
Sir, myself Shahnawaz Muhammad.
Yeah.
Basically, sir, my query is about, sir, the pattern of examination. Basically, what we read during the online lectures and all, sir. Can you please highlight about the level of the examination and what would be it about how much aggressive preparation we need for the exams? Like it had been very nice experience as of now, but it would have been much better if we finish it on a good grade. So kindly, sir, if you enlighten us something about examinations, sir, that will be of much help, sir. Thank you, sir.
Okay. Thank you for this query regarding the exam of this course of manufacturing of turbines. The pattern of exam for this course is multiple choice questions where you need to basically pick the right answer, or maybe there may be questions related to match the following and so on. Most of the questions are based on the content which is covered on the respective topic in this course, and for the sake of preparation, you need to be thorough with whatever content is being covered to clear the exam. So we are only having the MCQ, and the whatever is covered in the slides, most of the exam is will be there in the from the lecture itself. So I hope that answers your query. So any other participant, any query related to this course?
Excuse me, sir. Sorry,
Yeah,
I forgot. I have, sir, another question. Basically, sir,
yeah,
related, sir, lecture number 6. Sir, that was about from the section, sir. This gas turbine section, sir.
yeah.
Basically, in that, sir, we read about the economical considerations, like we read about material production and all, where we discussed, sir, those all of the elements and their usage, their cost considerations, sir. Sir, how much, how from what can you please, sir, recommend some specific book from where those sections can be cleared much more in a much more way, sir? That would be a help, sir.
As such, actually, for this manufacturing of turbines, there is no textbook. So, whatever content or the course content is being delivered in this course is gathered from, say, some books related to manufacturing materials and some research papers. Specifically coming to your query on uh, the economical aspects of the manufacturing the gas turbine. So as you see, the selection of material is very critical, because based on the material only the subsequent manufacturing processes can be planned, and the economics of any manufacturing any product, say gas turbine, are largely they are decided by the right material which is selected. So the material is generally selected, as you have seen in this course, based on the service conditions of the turbine. So based on that, the material is selected. And for example, the gas turbine, as we are talking, so you have seen why the super alloys are needed to manufacture the gas turbine. So I don't have any specific content like point. I cannot point toward a specific book or something, but whatever is there is gathered from several research papers and maybe some books which are there.
Thank you, sir. Thank you so much.
Okay, thank you. Any other participant? So some more participants have, I think, joined this meeting. So I will request if you have any queries related to the course. So please feel free to ask or discuss now. So any other participant, if you have any queries, so please feel free to discuss. Uh, Also, I would like to take this opportunity to like say, to summarize the contents of this course, the total overall contents. So overall, as you know, this course is regarding manufacturing of turbines, and specifically in this course, the theme is basically to discuss four types of turbine, which include the gas turbine, the hydro turbine, the wind turbine, as well as the steam turbine. So we all know that turbines are energy conversion devices, and these turbines basically they help to extract energy from some working fluid and convert it into electricity. So the theme of the course also aligns with the selection of the appropriate material for the turbine, wherein the selection of material is largely coming in from the service conditions of the each turbine. So as we have seen that each of the turbine, it has a different set of operating conditions. So to manage the operating conditions, the appropriate material is selected here, and this material is then basically the selection of material. They basically then it is deciding the future course of manufacturing processes. So just I'll summarize with highlights of some of the manufacturing processes for the turbines, starting with the gas turbine. So as we have seen that in the gas turbine, the turbine is basically operating in high temperature and oxidative type of conditions, where hot gases are produced by combustion of say natural gas as the working fluid. So temperatures of the order of 1300 degrees Celsius are produced, 1200 to 1300 degrees Celsius are produced. So in these conditions, the turbines has to operate. So therefore, as we had zeroed down in the course, the selection of the material was focused towards super alloys. So super alloys are basically a special class of alloys which can hold their hardness and strength at elevated temperatures. So we have seen in this course that this property comes in because of the unique microstructure of these superalloys, where the precipitates are, precipitated carbides are developed on the grain boundaries, which help to pin the grain boundaries. Because of the high temperature stability of these precipitate carbides, see the turbine or the material is able to retain its properties over a wide range of temperature, especially in high temperature region. So with this material, the process of manufacturing process start with say casting. We have seen some of the casting processes which are geared towards say a unique microstructure like directionally solidified microstructure or a single crystal microstructure. After that, we have seen that a special type of rolling process, or we can say a forming process, is used in gas turbines. So this basically helps to consolidate the microstructure, like say in case of in service defects which are generated, so the microstructure can be consolidated. After which we have the process which can lead to machining of the holes, film cooling holes, using say electric discharge machining or laser beam machining. We have also seen the use of finishing process in form of creep feed grinding in case of the gas turbines. After this, basically, we have seen the use of thermal barrier coatings, which are essentially there to enhance the performance of the gas turbines so as they can operate at higher temperatures. As we know, the gas turbines, they function on Brayton cycle, because of which higher the temperature of the working fluid, higher is the efficiency. So therefore, we have seen the use of the thermal barrier coatings, the different methods like electron beam, physical vapor deposition, atmospheric plasma spraying. These manufacturing processes were discussed. So moving on to the second type of turbine which was discussed in this course was the steam turbine. In the steam turbine, we have seen that steam turbines, they generally operate with superheated or ultra superheated steam. So the operating temperature does not exceed say 700 degrees Celsius. So in this regard, we have seen the use of say duplex sort of stainless steels or that type of materials to manufacture the steam turbines. Also, the steam turbines, they are relatively larger in size compared to the gas turbines. And in this regard, so the conventional manufacturing processes like CNC machining and so on are more than sufficient to shape the blades of the gas turbine. After which we have seen the use of some anti-corrosive coatings on the steam turbine. And largely the steam turbine material selection and manufacturing processes, they follow the conventional manufacturing process route. So then we have the third type of turbine, where we have the hydro turbine. So as we know, hydro turbines, they are able to produce energy by extracting the energy from flowing water. So the hydropower projects are set up where hydro turbines are used, and we have seen that in many of the popular hydro turbine projects. It is the Francis turbine or the Kaplan turbine, which is largely used because these are medium head, high flow turbines. Now, in case of hydro turbines, they possess a unique set of operating challenges. For example, in case of the rivers which are originating from the Himalayan mountains, so these rivers, they are perennial in nature, means they have the water flow throughout the year. But what happens, because of the sedimentary nature of the rock on the Himalayan mountains, so there is generally a lot of abrasive particles being suspended in the water which is flowing in these rivers. And what happens during the monsoonal season, when there is heavy rainfall, so the content of the abrasive or the particulate in the water, it drastically increases. Now, the presence of content, this slurry in the water, presence of this particulates in the water, they create a highly abrasive slurry, which can cause a lot of erosion on the surface of the turbines. So, if for these type of turbines, a unique material like martensitic grade of stainless steel, which are very hard, these type of materials are chosen. So these materials, they are started after selecting this material, the manufacturing process for the turbine starts with the casting process, where say sand casting is popularly used in case of hydro turbines. Why sand casting? Because sand casting, we have seen that it can manage very large components, and the hydro turbines are very large in size. So starting from there, so some of the forming processes like rolling and so on is also used to consolidate the microstructure. After which conventional processes like the CNC machining using milling and so on is sufficient to shape the surface of the or the shape of the blades of this turbine. So as we have seen the unique operating challenges in this turbine. So here the because of the hydroabrasive phenomena where a lot of erosion can take place. So here the use of thermal spray coatings has been discussed, where wear resistant materials like say tungsten carbide, cobalt, etc. are sprayed on the surface of the turbine. So this coating on the surface of the turbine, it helps to enhance the erosion resistance or slurry erosion resistance of the turbine, thereby enhancing the service life of the respective turbine. So lastly, in this course, the fourth type of turbine, that is the wind turbine, has been discussed. So with the wind turbine, basically what is there, as we know that wind turbine, it extracts energy from flowing wind. So in this regard, the material selection is also towards this attribute. And we know these type of turbines, the blades are extremely large. Extremely large means, say, I can say the diameter of the rotor of the wind turbine can be as big as 180 meter to 200 meter. So for this large type of turbines, the materials which are selected have to be light in weight and high strength. So we have seen in the course that use of polymer matrix composites has been discussed, and these are very popular materials which have very high strength, and they have low specific weight and low stiffness. So these type of materials, they basically are multi-phased materials, and there is a wide variety of materials which can come in category of polymer matrix composite. So essentially these material, they have a reinforcing phase and a phase which is known as matrix specifically to the wind turbines. So here the specific reinforcement is in the form of say glass fibers and carbon fibers, and the reinforcement is in the form these are the reinforcement, and the matrix is in the form of say thermoset, which are basically epoxy based matrices, which are basically provide the very high strength, and basically they are able to cover the fibers, protecting it from the environmental damage. So these are basically the material selection in this regard for the wind turbine, where polymer matrix composites, specifically the glass fiber and the carbon fiber is used with epoxy as the matrix. So for this type of processes, for this type of material, the processes which are used, they include the molding processes, where we have the vacuum bagging, etc. are basically used. and after which the turbine is manufactured. So after which the coatings on these type of turbines are also important, because as we know, the wind turbines, they operate in conditions, say, which are offshore conditions and so on. So use of protective coatings on this type of blades also enhances the rain droplet erosion using epoxy or polyurethane. So these type of coating materials are used. And we have also seen in the course the overall performance evaluation of for various of the turbines and the properties of the turbines, how they get influenced. So in the summary, the course basically discusses these four turbines, very important turbines, because we have seen these turbines, they are using both the renewable energy sources as well as the conventional energy sources. Nevertheless, the material selection, how the material selection, it influences the manufacturing process. That is all about the course on manufacturing of turbines. So with this, I still invite queries from the participants if they have any queries related to this course. So please feel free to discuss.
Sir, basically, as you rightly discussed, sir, the material selection is the most important thing which we learn from this course, sir.
Yeah.
Basically, I think, sir, sir, is it this material selection plus manufacturing processes for the manufacturing of the turbines, their blades, casing, and all. Sir, focusing on these parameters, is it sufficient, sir, for future course of action, knowledge, and this examination point of view, sir?
Yes, actually, because you see the material which is selected for the any turbine or say any product in general, it basically decides the manufacturing process. Of course, the course is dealing with manufacturing related, topics. So even you can say the material selection may also influence the economics of the product or say turbine in this regard, because it is the material of which any product is made largely decides its manufacturing process, of course, other attributes also.
Thank you, sir. Thanks a lot.
Yeah.
Hi, sir. Good evening, sir.
Yeah, good evening. Please go ahead.
Sir, in the turbine blade manufacturing, you tell that so there is another type of manufacturing system where the grain strainer is there, who strain the grain with a particular size. So, how the grain strainer is look like actually physically means it is not because all are in the molten state. So, how a particular grain size will strain in on that case to maintain a
So
the blade.
actually, yeah. So thanks for asking this question. So actually, the grain selector is used to basically decide the orientation of the grains, especially when we are doing, say, the directionally solidified or a single crystal cast material. So the grain selector or the is basically a opening. It is nothing special. It is a sort of opening, which is a small opening through which we slowly allow the molten material to pass through and solidify. And as the material passes through this grain selector in a slow manner, so it gets oriented. As it solidifies, it gets oriented in a particular direction. And so what we obtain after solidification is a directionally solidified blade or that type of a material using the material grain selector.
Okay, sir. So basically, sir, it is very small distance, nearly less than 1 mm or 2 mm, like that.
Means a small distance compared to say the size of the whole blade. So it will be a small opening through which the material is allowed to pass. So then it basically is, solidifies in the mold of the blade.
Understand, sir.
Yeah.
Sir, in India, is there any company who manufacturing blade like that?
So in India, the gas turbine manufacturing is not happening, but as I may have mentioned, so companies like Rolls-Royce and Pratt Whitney are popular to look at, which they have some R&D in India, but I'm not aware if they have the actual manufacturing of gas turbine using this process.
Okay, sir. The steam and the hydraulic turbines and all. Is there any manufacturing hub in
Yes,
India?
yes. So for hydro turbines and steam turbine, we have BHEL and these companies. BHEL is one of the leading company. L&T is also another company which are manufacturing into manufacturing of steam turbines or hydro turbines.
Okay, sir.
Yeah.
Sir.
Yeah.
Sir, the wind turbine blades after so how many lifetime? What is the lifetime they are operated for? How many year or something?
So the wind turbine blades, so these blades are basically designed to operate at least for 25 to 30 years in general. So their service life is in that range.
Sir, after complete of their life, they are just go for the means scrap. There is no use of these materials and all. The for landfill purpose only.
So conventionally, this has been happening that waste or the used wind turbine blades earlier they were going into landfills, but there has been a lot of focus on say some recycling technologies which can through which we can recover back the fiber or maybe separate the epoxy because as I just mentioned, this reinforcement in the form of glass fiber or carbon fiber in the wind turbine blade. So in general, these are very expensive, especially the carbon fiber is quite expensive to manufacture. So you see, just putting them into landfills will not make any sense and may cause other environmental issues. So there are several technologies these days available which can help to recycle the wind turbine blades, and using that we can reuse the fiber, at least the fiber, and some technologies may also be there which can say also we can get back the epoxy or that type of a thing. But more focus is on the fiber, and of course that fiber can then be put to use in some other polymer composite products. So that is also there.
Okay, sir. Sir, your research area is basically on this renewable energy or different sector, sir.
My research is mostly focused towards the manufacturing of polymer composites and their recycling also. Related to this only, our research mostly is focused towards different products, which include, say, the aerospace related products or wind turbines or maybe body armor, that type of things. It is related to several applications, but material and manufacturing processes are constrained with polymer matrix composites.
Okay, sir. So basically, I'm a BTech pre-final year student. So
Okay.
my HOD also working on this PLA material or to making this or self-healing materials. So if I
Okay.
want to go for, I'm interested in the renewable energy, sir. So if I get any chance to get an internship or something in this field.
Okay. So yes, you can see with there may be some opportunities related to internship at several IITs, so you can explore.
Okay, sir.
Any other participant? Any other query?
Sir,
Yes.
sir, the turbine blades, instead of go for investment casting, can we go for powder metallurgy also?
So, powder metallurgy, what will happen for powder metallurgy? You will be needing the raw material in form of, say, powder. So, the process will become very, very expensive, even more, it will be more expensive than investment casting. And more importantly, the surface finish of the casted or the product developed from powder metallurgy will be, say, relatively higher, surface roughness will be relatively higher. So I don't think that will be a viable option here to go ahead.
Okay, sir. Sir,
Yes.
sir, the apply of this thermal barrier coating, first is bond coat is then after top coat, na sir?
Yes, so first we have to apply the bond coat, and after that the top coat is applied. And as you have seen in the discussion, that it is mostly the bond coat. It acts as a matchmaker between the base material, which is, say, the super alloy, and the top coat, which is the ceramic based material in between. So the bond coat is needed there. So first you have the substrate, which is the super alloy. Then we have the bond coat, and on top of the bond coat we apply the top coat of the ceramic material, which acts as the thermal barrier coating.
Okay, sir. The ceramic material also not attached properly, na sir, because it is metal and this is non-metallic.
That is where the role of the bond coat is there. So it helps to attach it on the surface. So it can then help to act as a thermal barrier between the hot gases and the uh, substrate, which is the supralloy substrate.
Okay, sir. So the bond coat, whatever the if I apply thermal barrier, for example, in the iron, so the bond coat should have some iron particle, means some like that, sir.
It is not that way. Actually, for iron, you may be not needing, because it is not a super alloy. So, if iron base super alloy is there, so yes, some content of iron will be there, but alone iron may not be used in such application. Iron base
Uh,
super alloy can be used, not iron.
means my main purpose is, sir, in bond coat have some material so that it can adjust with the parent
Yes,
material. So that is the
yes, yes,
okay.
yes, yes. Some composition has to match with the base material.
Got it, sir. Got it.
Yeah.
Thank you.
Sir, what is difference between Bridgman furnace and liquid metal cooling?
Can you please repeat your question?
Sir, difference between Bridgman furnace and liquid metal cooling.
Okay, so Bridgman furnace, as we have seen, the Bridgman furnace, it offers lower, G by R ratio. So basically, in liquid metal cooling, the rate of cooling is much faster, because of which large size grains can be, small size grains can be developed in a particular direction. So it is basically the cooling media which is changed in case of liquid metal cooling compared to the Bridgman furnace.
Sir,
So,
what is the advantage in dipping and heaving process?
yeah, but please repeat. Your voice is breaking.
Sir, advantage in dipping and heaving process. Sir, I can't hear you.
Yeah, sorry. So in the dipping and heaving process, so as you have seen that the high thermal gradient is there. So advantage is basically we can get very high thermal gradients, so which can lead to a very desirable grain structure in the gas turbine blades especially. And then this type of dipping and heaving process where we dip it in the liquid metal, it also helps to efficiently transfer the heat. And sometimes the thin shell molds, they also are basically which are very good in extracting the heat from the molten material. So as you have seen, it is a very simple process, and because of high heat transfer capabilities, so required microstructure can be developed.
So we need higher thermal gradient, which is better.
Yeah. Yes. So I think we had a very good session where participants have asked their queries related to, of course, the evaluation pattern, and specific queries related to the topics of their interest. So in this session, we have also tried to summarize the overall course content, the theme of the course. So I hope it was very useful to all the participants of this course. So with this, now we come to the end of this live session of this course. So thank you for joining and best wishes.
Thank you, sir.